Okay, so what I did so far, guys, I explained key maps. You can see using key maps, it's very easy to do simplification comparing to algebra manipulation. Much easier, okay? Just you have to be careful when you select, when you create groups, as I explained to before. So I explained it for two variables, also 3 variables. Also, I explain don't care. Sometimes it's not always, but sometimes we have don't care. Okay. So as I explained, don't care means I don't care if the result is 0 or 1. Okay. The good thing about don't care, as I explained here, we can, if it is good, number one, you don't need to cover the don't care. What you have to do, you have to cover the ones, as I explained before. Okay. However, if it is good for me, if it is good for the simplification to consider some don't care as ones, go ahead and do it. Okay. So that's why here I told you without simplification, without don't care, and with don't care. So if I take don't care here, I can make big group, as you see here. This one is a small group. Anyway, so, and we are gonna have a quiz on Wednesday. This quiz is gonna be about 3 variables, okay? And it will have don't care. Also, lab 6, it's also for 3 variables, and also it has don't care, okay? Also, last time I started to explain for variables, okay? And you are not going to see big difference between what we did in case of 3 variables or 4 variables. It's the same idea, but somehow you need to know how can you create groups. But it's the same, everything else is the same idea, okay? So this one is not going to be in the quiz, but in the test 1, is going to be for, it's going to be 4 variables. So in the quiz, I'm going to test you in 3 variables, but in the test is going to be 4 variables. So as I explained last time, this is, as you see here, this is the map. This is the map we are going to use for in case of 4 variables. This is the map. You can see this map has how many squares? 16 squares, because as I said before, in this case, we have 16 min terms or 16 rows. For every row, we have one square for every row, as you know, okay? And also, I told you have to be careful here. You have to be careful here when you number the square. So this is min term 0, 1, and then 3 and 2. So this, the last 2 columns are flipped. Okay, same thing, switch it. And also the last 2 rows are switches, okay, out of order, okay? So you need to know how to do it. Also, this is the map we're gonna use. Similar to what I did before, this is the area of Y, and this is the area of Y prime. So Y prime is here, Y is here. If you look at all terms here, you will find Y prime. If you look at all terms here, you will find Y. Same thing, it's the same thing if you, for X. So this is X, and this one here, these 2 are actually X prime, okay? For W, we start by W by the way, okay? So here, W, X, Y, Z, and W is actually the least significant bit. Z is, W is the most significant bit. Z is the least significant bit, okay? So this is the map in this case. If you change them, if you make here X, Y, Z, W, if you start here W, X, Y, Z, so the map has to change. So this map for this specific case, when W is the most significant and Z is the least significant, and we can, but I'm gonna try to stick to this all in this semester. However, it may happen to online or anywhere to find sometimes they do some change here. So if you do some change here, you have to do changes here as well, okay? So for example, if this is Z and this is W, so here Z should become W and W should become Z and so on. Anyway, so, and similar to what we did before, if I give you the truth table, it's easy to map the ones here. See, this is similar to what we did before. Number 1, you have to put the ones here in given the function. I can give you the function in truth table, or I can give you the function in min terms, or sometimes I can give it to you in max terms, or I can give you as a function, as symbols, okay, in symbols, as a function in x, y, w, and so on. In all cases, you should be able to map the function here, okay? And what this means, it means this function is going to give 1 in these cases, in these min terms. In any other min terms, it's going to give you 0. This is definition. I define the function this way. Anyway, similar to what we did before, after you put the ones here, okay, you need to make groups. You need to group these ones as we did before. Number 1, you must cover all ones in groups. This number 1, you must. Number 2, try to minimize the number of groups, because for every group we are going to have 1 term. So by minimizing the number of groups, I'm going to minimize the number of terms. Number 3, if you have a small group, for example, this one can be a group, or I can take these 2 together. Bigger groups are better. Why? Because bigger groups, the number of variables in the term is going to be small. Okay? Anyway, so here we made the definition before about adjacency, or who are the adjacent or the neighbors of each square. I made the definition before. I told you a square is a neighbor for another square if there is only one change in the variable. So for example, these 2 are neighbor. So if you are confused at any time, you can just try to see if there is a change in one variable or not. So here w prime, x prime, y, but here is z and z prime. So there is a change in one variable, so they are neighbors. Okay. Anyway, that's what I did before in case of 2 variables, 3 variables, same thing here. So based on that, every square here has 4 neighbors. Okay. 2 vertical neighbors and 2 horizontal neighbors. Okay. So for example, this cell here, maybe this. So let's start with more straightforward case. Okay, so for example, this neighbor here has 2 horizontal and 2 vertical neighbors. So these are 2 neighbors, and 2 neighbors. Okay, same thing for this one. Okay, so this one has neighbors. These 2 are neighbors. These 2 are neighbors. These 2 are neighbors. These 2 also are neighbors. Okay. One more thing I told you last time is, actually, every cell here is a neighbor to the other cell. That's why I told you can imagine this map is like ruled this way. Okay, so we rule it. So when you rule it, so actually, if you rule this way, so actually this one becomes neighbor to this one. Okay, that is same thing here. You imagine it is also ruled this way. Okay, that means for this one, this neighbor, but also because it is ruled this way, this also a neighbor, and this one is a neighbor because it's ruled this way. Any questions? So every square has 4 neighbors. Is that okay? I give you here several cases. For example, this is a neighbor, and this one is a neighbor as well. Okay, neighbor, and this one is a neighbor as well. Again, if you are confused at any time, you already know what is the definition for neighbor. Okay. Any questions? Okay, so I just give you now, as we did before, you need to make groups. So now when you make groups, you can have only one square as a group. You can have two squares. You can have 4. You can have 8. Is that okay? For sure, 16 is going to be very extreme case. Do you know what 16 means? It means all of them are ones. So that means I can make only one group, and then in this case, f is equal to 1, because the function is going to give me 1 all the time. So we can assume this case can happen, but again, this is a very extreme case. Okay, otherwise the function is going to give 1 all the time. Okay, but anyway, so that's why I'm going to focus on if you have group of 1, group of 2, group of 4, group of 8. Any other groups are not allowed. It's not allowed to have group of 3, group of 7, something like that. 9 is not allowed. Okay, so let's start if the group has only one cell, like this case here. This is just 1 is here. In this case, so the term is going to have 4 terms. So if you have only one group of 1 cell, 1 square, so in this case you are going to have only you are going to have 4 terms here. In this group, you are going to have 4 terms. if you can merge, this is the beauty of it. If you can merge two ones together to create one group, I can reduce the term to three terms, to three variables. If I can make four, as I'm going to explain right now, if I can make groups of four, so now the term is going to have two variables. Okay. And if you can make groups of 8, like this one here, these are 8, as I'm going to explain, the term is going to have only one variable. You understand what I'm saying? So anyway, let's give more details. So now, okay, so this is for one. For one is going to be this way. And I don't want to keep repeating it. I'm expecting from you, once you have one here, you should be able to get this term, okay? The easy way to do it, as I told you before, try to see, for example, here for W, this is W, right? This term should be in the area of W prime. That's why I put here W prime, right? Now let's look at X. It is in the area of X. That's why I'm putting here X. Look at Y. It is in the area of Y. That's why I'm gonna put here Y. For Z, it is in the area of Z, so I can put here Z. So it's very easy. You can extract this one from here, okay? By the way, I don't want you to memorize this map. So I'm gonna give you this map in exams, okay? Same thing for 3 variables. I'm gonna give you how the map looks like, okay? Anyway. So now if I can make group of two squares, so how I can do it? Neighbors. So this one has to be a neighbor to this one to create only one group. As you see here, once you create one group, you can eliminate one variable. Instead of 4, it's gonna become 3. You can remove one variable. Okay. So now given this group, how can you get this term from here? Similar to what I have just explained. This is W, this is W prime. So it has to be W prime. Is that okay? Let's look at X. This one, these two are located in X, in the area of X. Okay. Let's look at Y. They are located in the area of Y. Let's look at Z. They are not located completely in Z or Z prime. Half here and half here. And this is a term I have to eliminate. You get what I'm saying? So it doesn't have Z prime. Okay. Anyway. In other words, that means this group is actually the intersection of W prime, X and Y. Okay, what do you mean? What I mean, this is the area of Y, W prime. This is the area of X. So far, this is the intersection. So far, if I add Y this way, it becomes this is the intersection here, okay? Which is 2. Now, as based on the definition of neighbors I made before, you can take these 2 as neighbors, right? These 2 are neighbors, and I can get this term this way. Also, these 2 can be neighbors. Okay, I give you this term this way. Also, these 2 can be neighbors this way. Okay, because this one is neighbor to this one. It's also neighbor to this one. Any questions? In case of if you can make groups of 4, so in this case you can reduce one more term. Okay, so instead of 3, I can make two variables. So that means you need to eliminate 2 variables. Okay, so how can you make group of 4? As you see here, they can be 4 this way. So you can take the. I'm gonna show you different ways for a group of 4. This one, if you have 4 this way, you can take them this way. Or these 2 and these 2, they are neighbors, okay, because it's ruled this way. So actually, listen to me, there is no big difference between this and this. Why? Because this one is ruled this way. If it is ruled this way, these 4 ones are going to be similar to this case, next to each other. Anyway, so again, so given this one, how I can get the variable here? Again, if you look at W, so these 4 are not located completely in W or W prime, so I have to eliminate W. Okay, let's look at X. Half of it in X, Y, or let's take them one by one. So here X, yeah, these ones are located in X, so I'm gonna put here X. Okay, Y, I'm gonna eliminate Y. as you see here, half of it inside y, the other half in y prime. So I'm going to eliminate y. If you look at z, it is inside z. Okay. In other words, these four are actually in the intersection between the area of x and the area of z. So this is the area of x, and this is the area of z. The intersection is going to give you these four. Okay. Same thing for this one here. They are neighbors. Okay. I'm going to leave this one a little bit for some time. So here, these two also neighbors. These two are neighbors. Okay. These four are neighbors. These four are neighbors. Okay. Please, these four are not neighbors. I didn't say that. These four are not neighbors. Okay. They have to be either horizontal or vertical to make them neighbors. Okay. The last one, which may be a little bit tricky, is these four here, this one with this one, with this one, with this one are neighbors. Why? Actually, this one, it's similar to this case. It's exactly similar. Why? Because as I told you, this one is actually neighbor to this one. Okay. So, and here it's also neighbor to this one also neighbor to this one. So if you see, these two are neighbors and they are neighbors to these two. Okay. So here, so you can take these four together, okay, as one group. And in this case, let's do the equation here. Okay. The equation is, let's start with W. So I have to eliminate W. Okay. I'm making it very easy. If you have a group of four, you should have only two variables. So you need to eliminate two. Okay. In total, we have four variables. So here for W, half of it, this is the W area, half of it in W, the other one in W prime. So I'm going to eliminate W. For X, all of them are in, this is X. All of them are in X prime. So that's why I'm going to take X prime. All of them are in Z prime. So that's why I'm going to take Z prime. Half of them in Y, the other half in Y prime. So I'm going to eliminate Y. In other words, just to make sure I did it correctly, if you find the intersection between the area of X prime and Z prime, you will get this four. Okay. Why? Because this is X. X is here. So X prime is this one here and this one here. This is X prime. Okay. This is number one. Number two, Z. Z is here. So Z prime is actually this one, this area here and this area here. If you take the intersection, you will get this four. Any questions? Okay. Now I'm going to move to group of 8. Okay. I'm going to show different cases for group of 8. Okay. So we have this 8 together here. I can take this 8. In case of 8, it's a very big group. Okay. This term can have only one variable. Okay. So that is why in this case, so you can find this 8 squares are only in one area. Okay. So for example, if I look at W, this is W prime. Okay. So it has to be W prime. Is that okay? So if you look at X, it doesn't have, because half in X prime. So I have to eliminate X. If you look at Y, this is Y and this is Y prime. I have to eliminate Y. Okay. Same thing for Z. The other way I can make eight groups. So because I told you this one is ruled this way. It's ruled this way. So these four are actually neighbor to this four. So you can see they are next to each other. Okay. That's why I can create one group here. And this group actually is going to be Z prime. Z prime. I can take this 8 as one group, which is Z. I can take this 4 and this 4 as one group. Okay, because it's ruled this way. Okay? And this can give you X prime. Any questions? Okay. Now, similar to what I did before, given this map here, I need to create groups that can cover all ones. I have to be careful when I select the groups because I need to minimize the number of groups I try to maximize the size of the groups. You have to be careful. So I have too many examples here. So let's start here with this example, okay? Let's look at this one here. What options do you have for this one? I have only one option, which I just like, this one has to be a group by itself. I don't have any other option, okay? Because no, there is no one here. The neighbors, the direct neighbor don't have any ones, okay? And for sure, I can't make something like that because they are not neighbors, okay? So this one, I don't have any option. This one can't be in a group. So it has to be only one term this way, okay? Let's look at the other ones. So this one already covered. Let's take them one by one, okay? So let's think about this one here. This one here. I can take it alone, or maybe it's a better option if I take it with this neighbor here. For sure. So I have two options here for this one. I can take it alone, or I can take it with this one. For sure, group of 2 is better than group of 1. That's why I decided to take it with, as I create a group this way, okay? Now, so I already covered this one. I already covered this one. I already covered this one. Is that okay? Let's look at, still we have two ones. Let's look at this one. What option do you have for this one? I can take it alone, or I can take it with here. And I told you overlap between groups are okay. Subset is not okay because you are going to create a redundant term. This is overlap because this is one group is this way, and then it's going to overlap with this group this way. Okay? So for sure, group of 2 is better than group of 1, and that's exactly what I did here. So I'm done with this one. Now the last one I have, this one. Again, the only option I have is I can't make 4 for sure because this is 0, not 1. So the only options I have is I can make it one group, or I can take it with the next one. So it will be better for me if I take them this way. Okay, that means 3 groups are overlapping here, which is okay. So you can see here this group, and this group are overlapping here. Overlap is okay. Subset is not okay. Okay. Any questions? Okay. Let's take another. I have too many examples here. I may not teach all of them, but you need the best way to understand this topic is just by understanding these examples. If I give you a case like this one here, someone can say, okay, I can take these 4 together. I can take these 4 together, and then I can make group of 4 this way. Okay. If you do that, you are going to have 3 terms. Every term has 2 variables because all of them are groups of 4, 2 variables. Okay. Is that the best thing you can do? The answer is no. This is not, again, as I said before, as long as you cover all the ones, this function is correct, but it is not the most simplified function. As long as you cover all ones, the function is correct, but it's not the most simplified. Okay. So what you can do here is actually, instead, what I did here, I just took these ones as one group, these here ones here as one group. Okay. However, I can merge them together and make only one group because, as I told you, they are neighbors. So instead of creating 4 and 4, so actually what I can do here is I can take, let me have a different color here. Yeah, I can take this 4. I can take this 4 here, this way, and this 4 this way, making only one group. Okay. Okay, so if I take this 4 and this 4, making one group, I can reduce it. I can reduce, instead of having here 2 terms, okay? So I don't know which 2 terms. Anyway, so I can just reduce it to only one term, and this term has only, which is, so this one is actually x prime. So yeah, this term. So I can take 2 terms and I reduce them to only one term. This one. I think these 2 terms. Anyway. Okay. Okay, what about if you want to keep these ones this way? So you are going to have, so these ones actually are going to be z prime. These ones here are actually z prime x, right? Yeah, this one x is z prime. So what I did here, I just these 2 became only one thing here. Yeah, this one. Okay. So now if you wanna, and then what about the other ones here? So I already finished this 4. I already finished this 4. What about the other ones here? Okay, if you wanna keep this group this way, so you are gonna have this term here. Is that okay? But I can simplify this term more. I can simplify it more. Why? Because instead of you make a group of 4, I can make group of 8. Look here, so I can take this together here. Okay, so that's what I did here. So I created, if you look at the green line here, it's gonna be one group, okay? And this is one group. So by this way, I can cover all ones using only 2 groups. Every group has 8 squares. That's why I have, this is the most simplified version. Any questions? Okay. I have several another cases here. If you have these ones here. So, for example, if I look at this one here, let's start, take it one by one, okay? I can take this one alone, or I can take it with neighbor. Is that okay? For sure, it's going to be better if I don't have any other option. The best option for this guy is to take it with the neighbor. Okay. What about this one? This one doesn't have any option unless the only option I have just alone. This one is alone. Okay. And then this 4, I can take this 4 together. By this way, I can cover all of them using 3 groups. Is there anything better I can do? I don't think so. Okay. However, some students may make another group this way. Okay. This is gonna create a redundant term. Why? Because these 2 ones are already in groups. They're already covered by groups. Okay. So if you cover them again, they already covered. So I'm gonna keep the function is correct, but it's not the most simplified one because you added a redundant term. You understand what I'm saying? Because we already covered here. Someone can tell me, but this is intersection between groups, already intersection. It does not subset, not intersection. That's totally fine, but already covered. Why you cover them again? Already covered. You have to be careful about it. These are an easy example, but the more we have ones here, it's going to become, I don't want to say difficult, not something difficult, but you need to be more careful. Okay, when you do it. That's what I want to say. That is what, think about it. What if you have 5 variables? So this one will be bigger, and for sure, don't get by our surface, it's going to be harder. That's why we are going to stop at 4 variables for this one. And if it is more than 4 variables, we can use computers can do that. Computer programs can do that. Okay. Anyway, so let's look at this case here. For sure, I can take this 8 together. Once you have 8, okay, I'm happy. Yes, I have 8 here. So I can take this 8 together. For this one here, you have 2 options. Either you take it alone, or you can take it with this one. So 2 is better than 1. So I'm gonna make it this way. Okay. Now, so I finished everything except this one and this one. Okay. I need to cover them. I'm sure many students will take them as one group this way. Okay, they will do it this way. Okay, this is not going to give you the most simplified, because these 2, instead of making group of 2, I can make group of 4. Okay, why? Because, and this is maybe, I'm sure many students will forget it. Don't forget, these are neighbors. One group. So that's what I did. So I can take this one with this one, with this one, with this one to create only one group. Any questions? Good. So let's look at the next one here. Here, for example, I can first look for if you can make group of 8, because this is the maximum you can do, right? Group of 8 is the biggest ones you can have. So here I can, as you see here, I have this 4 and this 4 together. By this way, I can make group of 4. Sorry, a group of 8. Okay, I'm very happy with that. So now let's look at who is left. This one is left. This one is left. This one is left. This one is left. Okay, let's think about it. Let's look at these 2. What option I have? Okay, one option I can take them as one group this way, but this is not the best option you have. I can actually I can make 4. Instead of 2, I can make 4. Make sense? Same thing for these 2 here. I can take them together. I can take them together as 2, but this is not the best option. That's why, okay? So I can take these 4 together. Okay. Please be careful. Listen to me carefully. I didn't. Someone can say, look, yeah, we can a very nice group. Now we have group of 6. Okay, for sure. I told you we cannot make group of 6, right? This way, I can't make group of 6. Groups can be 1, 2, 4, 8, not 6. Okay. So anyway, so in this equation, I got this one, Wxy. However, if I take these 4 together, I can make it more simplified because I can reduce one term. And that's exactly what I did on the next one. So here, instead, I can simplify it more. Instead of having Wxy, it's going to be only Wx. Any questions? Okay. One more example here. When you have summation, the summation means these are main terms. These are the location of ones. So all what I'm going to do now, I'm going to just put ones here in these locations to have this one here. And then the first thing you need to look at is group of 8. Okay? Because this is the biggest one. And then group of 4 and so on. So for example, if very clear here, I can create group of 8 here. So these ones here are group of 8. Okay? One group. Perfect. And this group is going to be Y prime. Perfect. Now, I have this one. What is left? This one, 3 ones here are left. Is that okay? Okay. What's the option you have for this one? Okay. For sure, the worst option, I can take them individually. This is the worst thing I can do. The other option, I can make group of 2 here and another group of 2 here. Or someone can make group of 2 this way, group of 2 this way, group of 2 this way. But this is not the best thing you can do. Okay? You can make, instead of making group of 2, you can make group of 4. For example, as you see here, if I take these 2 together and they are going to overlap with this one, so this one already covered. Okay? And the last one here to cover it, the best thing I can do for this one is I can make it group of 4 as well. Okay, so as you see here, let's use a different color. So here, I'm going to take these ones here and these ones here. Someone, be careful here. Be careful here. Someone can say, let me make it and be careful here. Someone can say, man, wait a second. This one here is covered in 2 groups. Okay. This one here is covered in 3 groups, right? So this one is already in this group, in this group, and also in this group, okay? This one here also in 3 groups, okay? So then this create a redundant term. The answer is yes. A redundant term is going to be created if you make a group of squares. And every square in this group already covered by the other groups. And this is not the case here. So the case here is this one is already covered. That's okay. This one already covered. This one is already covered. That's okay. But this one is not covered. So that's why you are not going to have a redundant. So if you have only at least one that's not covered, so the group you are going to create is not going to be redundant. But if this one is covered by other term, and all of them already covered by other terms, you are creating a redundant group. Because already all the ones are covered. Okay. Any questions? So, in my opinion, I'm going to give you advice. If you listen, please listen to me. If you don't listen to me, you are not going to do it. Okay. The worst thing you can do when you study the slides, look, it's easy, group, look at the colors, it's easy, and that's it. It's not going to work this way. You have, okay, because if you just read it, you will think everything is easy, okay? The best way you have to do it is just to cover the solution and to try to solve it by yourself, right? and then compare your answer, this answer. If you just read I put too many examples. If you just read the examples, I'm quite sure in quizzes, in exams, yeah, it's going to be hard to do it. Okay. Anyway, so I have another example here. I'm going to give you this one here. Okay. And then I'm asking you to simplify this one. So all what you have to do first, from this one, you have to put ones here. You have to put the ones. How can you do it? As I told you before, because this term has 3 variables. That means this should be 2 ones, 2 squares, 2 squares, 2 squares, 2 squares. Every one of them is 2 squares. How can you find the 2 squares of each one? Is intersection. This is the easy way. So this one should be in the intersection of W prime. This is W prime is here. Okay. X prime is this one here and this one here. So until now, this is the intersection is here. Okay, let's continue. Y prime is here. So if you see the intersection, you'll find 2 squares. In exams, in something else or quizzes, man, listen to what I'm saying. I'm just trying to help you to avoid mistakes. Okay, I'm saying if it has 3 terms, it should be 2 ones. So in exams, if you make only one, it's one only. If you put only one, okay, so something is wrong, right? If you make it in four squares, something is wrong. Okay, so in case of you have 3 variables, that means you have 2 ones. Okay, so same thing I did. For example, if you look, but maybe listen to me. Maybe some squares are going to be overlapped here. Not maybe, because this one is not simplified. Because of that, one square is going to be in several terms here. Okay, because it's not simplified. Otherwise, it will be simple. Anyway, so let's see. For example, so already these 2 came from this one, right? As you will see, maybe we are going to have, because you are going to have here some other terms, maybe put ones here as well. Let's see. So for example, if you have here X prime, let's look at the next one here. Next one is going to be, as we see here, and this one here. So if you look at this term, it's going to put here 1 and put 1 here. Okay. If you look at this term here, look at the color. So you're going to put here 1 and where is it? I think it's somewhere else. So let's see. So this one is actually W prime. This is W prime is here, W prime, and X, so it's going to be X. Yeah, because this one is 4 terms, it has to be only 1. Okay, so that's why this one will be here, because it's 4 terms, only 1 is squared. Okay, so this one is only here. This one, it's going to be 2 ones, which is, where are these ones? I think this one and this one. Okay, let's see. It is in W, it is in X prime, and it is in Y. Yes, it's going. So that means, that's what I'm telling you. This square is actually, this one was 1 from this one and also this one as well. That's okay. Okay. Anyway, and then after that, after you do it, you can find here the best thing I can do. I can take these 2 together. I can make these 2 together, and I can make 3 terms. I don't think I can do better than that. Any questions? Okay. So, yeah. So just what I want to see here, I don't know what I want to see here is, yeah, for this case, this may be the best solution we can have. It can be this way. However, I'm sure because you are learning in the beginning, you may think I can create one group here. If you do that, you are going to have one redundant term. So I'm going to have the same 2 terms I have here. And then because this one is already covered in this group, this one already covered in this group, you don't need this group. But if you make it, if you make this group this way, and you don't need it, you are going to have to get a redundant term, as I said. Okay. Yeah. Now, when we have more ones, it's going to be, I don't want to say more complicated, but you have to be more careful. As I told you before, in most cases, the most simplified function is only one solution. Okay. However, in some cases, you can have 2 solutions. Both of them are okay. The most simplified, and this is the case here. So if I make groups this way, so using this one, I can have here, this is the most simplified, and this one is the most simplified. Two different solutions, both of them are the most simplified. Why? Here you can see we have 4 terms, here we have 4 terms, right? Here, every term, 2 variables, every term is 2 variables. So both of them are acceptable solutions. What I'm saying? That's why I think in last lecture, a student came to me and asked me, look, this is the solution, this is a most simplified solution. And then I looked at my solution, I found it is different. But that doesn't mean the student is wrong. Okay, that's what I'm saying here, because you can get different. Sometimes it happens, especially if you have too many ones like this. So let's see what are the different here. Okay, the first, I think both of them here agree these 4 can be together. So they did it this way. You know, okay, I'm going to tell you a trick here, a trick. Some groups are essential groups. Essential group is going to be in all solutions, most simplified solutions. Okay, which groups? Look here, for example, for this one here, this one has only one option to make them together this way. That is why if you have many solutions, all of them are correct, you will find this term in all of them. Because this one has only one option. This one has only one option this way. So this term will be common in all solutions. You got it? The difference will come when you have 2 different options and both of them are going to give you same simplification. For example, so we agree already this 4 should be in any solution you have. Okay. Same thing. We have another group here. I can call it essential. So essential means this group must be in all solutions because you don't have other option. There is another case here. The case is if this one is going to tell me the only option I have there, this one is going to have these 4 together. That's why this term has to be in all solutions because this is essential. You don't have other option. Essential term for this. However, the other terms maybe you have different variation. All of them are they are not essential terms. Okay. So again, essential term meaning you have only one option, right? Non-essential it means I can have multiple options, and this should happen for the other terms. So for other terms here, I can, for example, if I want to cover these 2 together, what I can do here, I can take these 4 together, or I can take these 4 together. They are going to give me the same solution. Not the same solution, the same simplification. Because if I want to cover these 2, I can take 4 this way, or I can take 4 this way. This case and this. So I can take 4 this case this way, or I can take 4 this way. So if you do that, what is left now? What is left is this one here and this one here. I didn't cover them yet. Okay. So for these 2, for this one and this one, oh, look here. For this one and this one, so actually I have 2 options. And the 2 options, by the way, I'm going to generate another solution right here. I'm going to make another solution. All of them are correct, okay, because of this one. So for these 2, one of the options, as I did here, and also the same thing I did it here. I take these 4 together, I take these 4 together, and the same thing here. That's why you will find this term is common. So this term is common, okay? So based on what I explained right now, the only difference between these 2 solutions is just this term, one term, right? Which here I decided to take these ones here, but here I took them this way. Only one term is different. The other terms are the same. I can have another solution, which is also correct, okay? Here, for these ones here, to cover these ones, instead of the green, I can cancel the green group that I have here and here, I can cancel it. And instead of that, I can make this one as a group of 4 as well. I don't know if it's correct or not. Think about it. It just came to my mind right now. But I think it should be okay. Think about it. You got what I'm saying? So by this way, I can have another solution. Yeah, oh, it's already there. So it's already there. Okay. Okay, guys. So yeah, so now I have three different solutions. Some terms are common. So you can see here XZ, because these terms are essential for any simplified solution. You should have these terms, okay? Some terms are not essential, but anyway, yeah, that's what I'm explaining here about what is essential, what is not essential, okay? Anyway, I don't think I need to explain this one here. Yeah, just I'm gonna leave it to you. Yeah, so here, same thing here. All what I did here, I will try to most of the time to use WXYZ, but it's the same thing. I can use A, B, C, D. It's the same thing. So instead of calling this one W, I'm gonna call it A. I will myself, I will try to use just WXYZ. But maybe when you read something online, maybe when you go to Zybox, use different symbols. Don't be confused when do little change like this one. Don't be confused. The only thing, instead of W, I'm gonna call it A, okay? And instead of WX, instead of X, I'm gonna call it B, okay? WXY, instead of Y, is gonna be C, right? And so, So if you do this, for example, if you do this way, so the best option I have here, I can take these four together. This is actually the only option I have for these four, and I can take these ones here together. Actually, there is no any other option here. Yeah. Unless you want to make group of two or group of ones. Anyway, any questions? Anyway, so I give you more example. I don't want to spend more time in this one, but yeah, so yes, the more ones you have, maybe the more it's going to be more, you have to be more careful about it, okay? Let's do this one and then we can move forward. So if you look at this one here, let's start with the essential ones. Okay, if you look at this one here, for example, this one can be only in one group, which is this group. This is an essential group, right? So that's why it has to be this way. There is no other option for this one. So this group is essential, okay? Now look at this one. Also, this one has to be here and here. So also this group is essential because this one doesn't have any other option. It's essential, right? So what is left? This one here, this one here, this one here. They are left, okay? For this one as well, this is an essential because this one here, it doesn't have any other option other than I'm gonna take them together this way, okay? The last one I have here is this one, okay? So this one actually is not essential because it has two options. They have two equivalent options. I can take this one with this one, as you see here. I can take this one with this one, or I can take this one with this one. By this way, I can make two solutions. Okay? One solution have three terms are common in the two solutions. The only term that's going to change is this term. If I take this one with this one, or I take this one with this one. Okay. Any questions? Okay. Now I'm going to jump into don't care. And again, nothing is new. If you have don't care, you have the option to take the don't care in groups if it can help you. You don't need to cover the don't care. You need to cover the ones that don't care. Okay, but if they can help you, I already explained it for 3 variables. It's the same thing for 4 variables. So here, for example, I wanna here let's look at these examples here. Assume here I'm making a definition what is don't care. I already explained it before. So for example, if you look at this one here, we have don't care here. Okay, so as you see here, I have only 3 ones. I want to cover these 2 ones and the 3 ones. So I have only 3 ones as you see here. Okay. However, it's good for me to cover these 2. It's good for me to consider this X like 1 and 1 and make a big group. Okay. For this one, I can take this one with this one this way, make 2, or I can consider this one as 1 and 1. I can make it 2 this way. By this way, if you implement your function, you are going to have 1 here, you are going to have 1 here, you are going to have 1 here, and then you are going to have zeros here. Okay. So some don't care. If good for me, I can make it 1. If it's not good for me, okay, leave it 0. Okay. Same thing here in this example. This is the way we write it, and this is the way I wrote it in the lab. It's written in the lab. So this is the main term. This is the location of ones, and these are the location of don't care. So if I map it this way, it's going to be this way. Okay. So again, I can cover this 4 this way, and then I can consider. It's good for me to consider the don't care as 1 to make group of 4. What about the other don't care? 0, 0. I don't care about that. Okay. It's not going to help me to simplify. Any questions? Don't be confused. I don't need to cover all don't care. It's optional. Okay, just to take whatever useful for you, whatever can help the simplification. I give you another example here. I just want to show you here. If, for example, here, I have don't care this way, because of this don't care is here, I was able to make group of 4. Okay, so here, because of that, this is a function I got. But if you don't take don't care into account, what you are going to lose? What I'm going to lose is, instead of creating group of 4, if I don't consider don't care here, so I'm going to make group of 2. By this way, instead of having the term that have 2 variables, I'm going to have a term of 3 variables. So don't care can help you, number 1, to reduce the number of groups, or also can help you to make groups bigger. Yes. Yeah. Yeah, this will be smarter than what, better than what I did. Yes, I'm going to correct. So very good observation here. What you did. No, wait a second. This case is we don't care into account. So, but here, yeah. So what I think what you want to say here is, instead having this group to kill, I can make a group this way, right? And I can delete this group, right? Yes, this is another solution. Okay? Nothing is wrong here. Okay? But yeah, instead of making group of 4 this way, I can make only 1 group of 4 this way. Yes, this is another solution. Okay. Here, and that's what here we are gonna design a circuit. And by the way, what I'm gonna do here in this example is exactly the same thing I'm gonna do in chapter 4. Okay. Now I'm gonna design a circuit. I want to design a circuit to do something. You have to start with the truth table. From the truth table, you have to go to the map to make simplification. That's it. Okay. So for example, I want to design a circuit. This circuit should have BCD input, because BCD input, so should have 4 inputs, but this 4 input should be from 0 to 9, okay? And 10 to 15 should not happen, because the input is BCD. BCD means a decimal number. I have 4 input. The output here should 0 or 1, okay? To tell me, I want to do a circuit that's doing that. I want to do a circuit that's going to tell me if the input is greater than or equal 5 or not. Okay? That means if the input is greater than or equal 5, the circuit is going to give me 1. If not, it's going to give me 0. I want to design logic circuit to do that. So the first thing I'm going to do, by the way, this example is exactly similar to what I'm going to do in chapter 4. Okay? So what I'm going to do here, I want to, as you see here, so starting from 0 until 4 here, I'm designing, I'm saying, this circuit has to give me 0 in this case. This is my choice. That's my design, because I want a circuit to give me 0 when the input is less than 5. If it's greater than 5, it shouldn't give you 1. From 10 to 15, don't care, because the input should not be in this area. If you put, that's what I'm telling you, the input has to be between 0 and 9. Okay? But you can input 10. You can do that. Okay? You can input 12, you can input 13. Okay? But the output doesn't make any sense. The output can be random 1 or 0. Doesn't make any sense, because you should not because it doesn't make sense to input 10. But because we have 4 variables, you can do that. You can put numbers as greater than 9. You can, but the output is going to be irrational. It doesn't have any meaning, right? So it's random, 0 random. I don't care. Anyway, so if I do that, I'm going to just make a map this way. Put all ones you have, and then put all x you have, and then do simplification. By this way, this is a magic. If I have a logic circuit like this one, this logic circuit can tell me if the input is greater than or equal to 5. I designed the logic circuit. This logic circuit, this is the design of the logic circuit. The logic circuit should have here W, X, Y, Z, and should have F here, and this F is 1 if the input is greater than or equal to 5. Any questions? This example is important because that's what I will do all the time in chapter 4, right? I'm gonna leave this. Yeah. So now I'm gonna leave this one because it's related to something I'm gonna explain right now. Okay. So now I almost finished everything. Only one thing is left in this chapter is what we call product of sum. Okay. So what I did so far in this chapter, is I was able to get the most simplified function in the format of sum of product. Sum of product. Is that okay? What if, and that's what I asked you to do in lab number 5. But in lab 5, we asked you to do it using algebra manipulation. Okay? So now what I did so far, guys, I was able to get the most simplified function in the format of sum of product. What I'm gonna teach right now is how I can get the most simplified version in the format of product of sum. Product of sum. Is that okay? How? I'm gonna tell you how. Look at how I'm gonna do it. Let me go back. Yeah, let me go back to any map. For example, yeah. Let's start with how you should have done it, or how I explained it in the video of lab number 5. How, if I give you this one here, and I ask you using Boolean algebra, I'm gonna explain how can you do it in algebra manipulation, and then I'm gonna explain how can you do it in maps. Okay. In algebra manipulation, how can you simplify this one and get it in the format of a product of sum, not sum of product. Okay, look here, guys. What I have to do is that instead of simplifying if you simplify f as I did here, you will get the simplified function in sum of product. If you simplify f, what I'm gonna do right now, I'm gonna simplify f prime. So what I'm gonna do is I'm gonna get f prime, for example, equal y, x, or x prime z, something like that. So instead of simplifying f, I'm gonna simplify f prime in sum of product. So I'm gonna get f prime in sum of product. Similar to what I did here. Similar, but instead of working on f, I'm gonna work on f prime. If you do that, you will get f prime in sum of product. But wait a second, man. I want to get f, not f prime, and if product of some format. Yeah, that is why De Morgan is going to help me. So De Morgan told me, if you have f prime this way, and you take De Morgan, f should equal xy or xyz bar of prime. Don't be confused, bar or prime. Is that okay? And so by this way, you can convert the most simplified sum of product to the most simplified product of sum. You got what I'm saying? How? So this one will become x prime or y and x or z. Is that okay? This is how it is. So again, in order to get the most simplified version of in product of sum, all what you have to do is, this is f, so I'm going to create f prime. In f prime, this is 0. Every 0 will become 1. Every 0 becomes 1. Every 0 becomes 1. Every 1 becomes 0. Is that okay? So here, this is f and this is f of prime. So every 0 becomes 1. Every 1 becomes 0. Is that okay? And then, similar to what I did before, I can work on the ones here. So I can work on the ones for f of prime. I can simplify it similar to exactly the same thing as I did before. Okay? But what I did before, I worked it on f. This time I'm going to work on f of prime. Okay? And then once you get the most simplified version for f of prime in sum of product, you can use De Morgan to convert this one to product of sum. Okay, this is how can you do it in Boolean algebra. In maths, how you can do it in maths, I'm going to tell you how. Look here, and this is the key point. The key point is that, look here, guys. Again, I'm going to make it very simple. In both cases, if you want to get sum of product or product of sum, in both cases, you have to work on the ones. Okay. The only difference is which you are going to work on the ones of f or f of prime. The only difference. Is that okay? So here, this one is 1, right? Because this one is representing function f. So for f, these ones are 1s. And this one should be 0s. This is for f. What if f of prime? In case of prime, if this one is f of prime, because I want to simplify for f of prime, not f. In this case, every 1 becomes 0, and every 0 becomes 1. Make sense? Because this is f of prime. Okay. Okay. So all what you have to do is that if you wanna get sum of product for f of prime, okay, the map of f of prime is similar to the map of f, similar. However, you have to flip the bits. So every 1 should become 0, every 0 should become 1. Is that okay? Make it very simple. I'm gonna make it very simple. Look here, guys. So what I did so far is I need to cover the ones. That's what I did. I need to cover the ones to get f, right? To get f prime, I need to cover all 0s and don't take any ones. Why? Because in f prime, 0s are 1s, 1s are 0s. You got what I'm saying? So now I'm gonna repeat everything I did right so far, but instead of creating groups for 1s, I'm gonna create groups for 0s. I need to cover all 0s, not all 1s. And if you do that, you will get sum of product for f prime. Simplified sum of product for f prime. Okay, guys? Again, man, so same thing as I did before, you need to cover all 0s instead of all 1s. You have to create the largest groups of 0s, not 1s. You should not put anyone in any group. Don't be confused, because these 1s are actually 0s. These 0s are actually 1s in f prime, right? That's exactly what I'm teaching here. So what I'm teaching here is, hopefully I didn't confuse you, but what I'm saying here, that's why this section is too short, because actually nothing is new. Nothing is new here. This section is actually 2 points. Number 1, same thing as I did before, but instead of covering ones, you need to cover 0. This number 1. What you are going to get is the most simplified sum of product for f prime, and then calculate De Morgan, and that's it. Very simple. Okay, that's why this one is too short. Anyway, so if I ask you in exams, in anything, you need to get sum of product. So that's what I have explained so far. If I explain to you, you need to get product of sum. That's what I'm going to explain here. Okay, which is actually same thing like what I did before, but you need to cover 0s. Okay, so let's start with this example here. Okay, so you have this function here. All what you have similar to, everything is similar to what I did before about groups, about neighbors, everything is identical. The only thing is I need to cover all zeros, and no one should be in group. By the way, here I'm working on, this is a map for F. But if you map for F prime, so everyone here it actually is 0, and every 0 here is 1. But you can just simply, I can make it simple and say just work on the zeros. But actually I'm working on the ones, not the zeros. Because the zeros for F, because this is the map of F, the zeros for F are actually the ones for F prime. So anyway, so here same thing as I did before. You need to create groups of zeros. Your groups should not have any ones. Similar to what I said before, your group should not have any 0, but now we should not have any ones. You need to cover all groups. However, what you are going to get here, is actually F prime. So now I can say, based on the simplification I did here, this is F prime. And then you can use De Morgan to convert F prime to F. By this way, what I got here is actually the most simplified product of sum. Any questions? Okay, another example here. I just give you this function this way. So now again, I'm gonna work on zeros, not ones. Your group should not have any ones. Okay, very clear. I said it many times. By doing that, by doing the simplification as I did before, everything is similar to what I did before, but you just work on zeros. Okay, but you keep in mind, yes, you are working on zeros, but actually these zeros are ones because I'm calculating F prime. Okay, so but anyway, so I just want to work on the same map of F. Or you can create another map for F prime if you want, but I just make it easy. Just create map for F as we did before and work on zeros. Okay? Then I'm gonna get this one here. So again, the other way you can see it, if you don't like it to make it this way, I can say if I give you F this way in exams or whatever, so F prime should equal the summation of any other ones here. So you have already 0, 1, 2. So here should be 3, 4. You have here 5, 6, 7, 8, 9, 10, and then you have 11, 12, 13, 14. Is that okay? And then you can work on this one if you want. By this way, you can put ones here. And here, this one becomes zeros. Yeah, you can, and you can tell me this is F prime. This is a map for F prime. So if you have F, it's easy to get. But anyway, I just don't want to overcomplicate it. Just work on the Z instead of one. That's it. And this way, you are going to get F prime. Okay? And if you work on ones, as I did before, you will get F. The sum of product for F. But now I want to get it sum of product for F prime. And once you have F prime, you can easily using De Morgan, you can get F. Yes. Should be what? Should be. No, because that's a good question. Because these are min terms, right? So sometimes we say M lowercase, sometimes we make M uppercase. M this way, these are min terms, these are the locations of ones. But these ones here should be the location of zeros, max term. You got what I'm saying? But this case here, these are the location of ones, so these are min terms. You got what I'm saying? These are the min terms. Because this is the map of F, right? So again, just in one sentence, if you have the map of F, if you work on the ones, only ones, you will get the most simplified sum of product for F. But if you work on the zeros, you are gonna get the most simplified version for sum of product of F prime. Okay. And because this one is the most simplified one, this one also the most simplified one. Because this one is the most simplified one, this one also is the most simplified one. Anyway, so same thing here, we can also have here don't care, okay? Yeah, there is one example I left here. Okay, so here in this example here, I can tell you this is F, This is a function f, and then I give you by. So these are the max terms. These are the location of zeros. And also I tell you we have don't care this way. Is that okay? So as you see here, these are the location of zeros. So yeah, I'm gonna put here zeros. And the don't care here, don't care here, and zero. So, and similar, because here I'm asking you to get f in product of sum. I want you to get f in product of sum. Is that okay? So that means you have to work on f prime, okay? And then once you get f prime, you can easily move to f this way. Yes.
That bar looking thing is telling us to look for the product of sum, right?
Which part? This one? This one?
Yes.
No, sir. No. This is how I define the function. When I define the function, I can define it using summation or using by. Summation is going to tell you the location of ones. By is going to give you the location of zeros.
Zeros.
You got what I'm saying? So here I define the function by giving you the location of zeros. I can define it using some. It doesn't mean every time I give you by, you need to get product of some. No, I can give you by and ask you for some product. You got what I'm saying? So I have to be clear. I have to tell you in exams, this is not something you can guess. I have to tell you, give me this function in product of some or some product. And by the way, why we have two versions? Why sometimes we can anyone answer this question? Why we have two versions? Sometimes I want why it's not only one format or one form and just all the time I'm going to use some product. Why sometimes you should be able to get any function in some product and product. So can anyone answer this question? Yes.
Because it might be easier one instead of the other.
Yeah, this is one.
Like the product of sum might have less.
Yes.
Less spots on the K-map, so it's simpler.
Maybe, but there is another reason. Okay, this is one reason. Maybe I'm gonna look at some of the product sum and then pick the most simplified one. Maybe this one reason. Yeah, what is the other?
I was gonna say that the one that has the least amount of terms will have the least amount of components they get to use. So
Yeah. That's exactly his answer. That's what he said. I can look. No, but it's not. There's another reason, guys. What is that? This is one reason, but there is another reason. The other reason is for some product, I can implement it using NAND gates. Product of some I can implement using only NOR gates. Okay. So for example, the manufacturer, I want to manufacture a chip, and I'm going to tell you I want to use only NOR. That means you have to get product of some. If I tell you I'm going to use name to implement it. You understand what I'm saying? That's what I explained earlier. So what I explained what I explained before is you can implement this one using only NOR. Okay, if you go back what I explained before, it was like that. You can use only, I think, you only one NOR this way, and for every term here you can use one NOR, I guess. Anyway, you can go back and see how I made it, but you should understand it depends on what electronics you want. You want to use electronic circuit for NAND or NOR. Okay? And this is something I think in the data sheet. I think they can say in some chips, they can say, and this is something actually the manufacturer like. So the manufacturer of the chips, they like to implement the circuit using only NAND or only NOR. They don't like to have a circuit that have or and not and something like that. Everything I can implement everything using only one type of gate, NAND or NOR. Any questions? So I'm done with this chapter. We're gonna start next time. As I told you, we're gonna have a quiz. The quiz is not gonna be in this lecture, but what I told before, it's gonna have only one question. This question is gonna be about 3 variables. I'm gonna give you a function. This function can be in any format, truth table, min terms, max terms, okay, or maybe a function as in symbols, x and y, whatever. And then I'm gonna ask you to simplify this one. There will be a don't care as well. So there will be don't care. I will ask you to simplify this function using, it's gonna be product of sum, sum of product. Okay, not what I told before today. Okay, everything I told before. Sum of product, not product of sum. Okay, so you have to work on the ones, not the zero for this one.